Welcome, everybody, to Bring It Home, the show about American reindustrialization, the manufacturing renaissance, and all things reshoring. I'm your host, JP Hampstead, here today with Brooks Mendenhall from Astronomy Magazine. Have a really cool and unique show planned this time. We're here to talk about SpaceX's Starship, this massive, impressive spacecraft and launch system that's been developed really since the late 2010s. In recognition of its successful 10th test flight, which happened on August 27th, a bit earlier this summer, we decided to look at the Starship from an American manufacturing point of view to talk about how it was built, what its capabilities are, sort of the entire manufacturing philosophy behind it, which is very different from the way that other spacecraft of similar size and capabilities have been built. Brooks, did you watch the test flight? What did you think?
Yeah, I didn't watch it live. I was a little spaced out that day. I had been interviewing William Pomerantz at AeroVironment about Skyfalls, like this cool Mars helicopter. And so when I got off that interview, I just sort of tuned out all the space news. But then the next morning, I watched the replay footage of the launch. Super, super cool to see.
What did you think? Were you most impressed by?
I mean, I think since I've been covering space exploration, just any time a launch clears the tower, like that moment of like the volume and the noise and is really exciting. With this in particular, seeing the separation, the hot staging, where the spacecraft itself separates from the booster was super cool. And then also the Pez dispensing.
Yes, the dummy satellite deployment.
Yeah, satellites popping out one at a time was exciting as well.
So let's dig into this launch, and we can talk about why it was so important to SpaceX. They had some initial early successes testing Starship, and then ran into a string of pretty spectacular failures, or as they like to call them, what is it, rapid unscheduled
disassembly?
Yeah. Rapid unplanned disassemblies. So what it had, I think 7, 8, and 9 all failed for different reasons: fires, explosions, loss of attitude control on reentry. And so this was kind of like a make or break, not necessarily a make or break launch, but the pressure was on. There was an article, I think, in the New York Magazine, questioning the entire design of Starship, sort of saying that because SpaceX had these really ambitious payload requirements for the spacecraft, that they were having to essentially construct it and make it too light, right? They weren't putting enough sort of structural support in it, so that the math worked out for a large payload, but that was causing things to not work. There are other authors who just kind of don't like the idea of reusable space planes in general, and so there were a lot of questions. And on the other side of that, there are plenty of failures leading up to it. At the same time, a variant of the Starship is still planned on being used by Artemis 3 to land on the moon in 2027. And so you've got failures, and you have this kind of hard deadline where they have to get this thing working really, really well. So tell us about what happened in test flight 10.
Yeah, I think too, thinking about test flight 7, 8, and 9, it's important to remember that failure is a large part of the SpaceX process, right? Failure is where they learn and then go back and figure it out. So in some ways, sometimes the headlines, I think, sensationalize the failure component of it and overlook that's bound to happen.
But yeah, that's a really good point, because during the first space race in the Cold War, there was so much pressure, political pressure and social pressure being put on the space program. It was propagandistic purposes, things like that. And like, the like mission failure, like you have like the whole famous like sort of apocryphal Gene Kranz quote, like failure is not an option. Um, they had all these manned flights and things were almost like over engineered so that there was like no risk of failure. Whereas, as especially as we'll see like later in the program today, um, failure and iterative design improvements are part of the
It's a
SpaceX
huge,
manufacturing
a huge
process.
part of the process. Yeah. So for this, with that in mind, I think for this launch in particular, they were running like a number of experiments to test the viability of Starship. And so, like in this flight, there were I think like 5 experiments that they ran. So one is that like the booster separates from the upper stage rocket and then comes back to Earth, and it has 33 engines, but then 3 central engines, right? And so those 3 central ones are the ones that are supposed to be used for this landing burn, but they simulated like what if one of these engines was out, and so it lands with 2 of the central engines and then a third engine from one of the outer ring engines. So that was one of the tests that they ran, and from what I understand, it was successful. Although I think the booster like burned up when it landed in the Indian Ocean, right? Like,
Yeah, they exploded when they landed in the Indian Ocean, but that was also planned. I mean, it's basically like you're landing like this super hot, like
yeah.
30-story building in the ocean that's like full of like methane and oxygen vapor and like tipping it over.
But in the long run, like future versions of Starship will land with the little chopstick arms, like catching them, bringing them back to the launch pad, which is pretty cool. And then some of the other experiments they ran too, the Raptor engines on the Starship itself, like the ship, not the booster, relit like above Africa briefly to test like whether or not that's possible for those engines to relight, which is super important if you're trying to get payload to the moon or to Mars for that to be possible.
Or even to a specific orbit. And then there's another cool one. A lot of people that watched the initial broadcast of the test commented on like these like missing thermal protection tiles that were pieces of it were clearly like off. That later on they said that they had removed 16 tiles to like stress test the spacecraft, and they had done some more aggressive maneuvers during re-entry to put extra stress on like the flaps and fins of the Starship, and actually tore them up quite a bit.
Yeah.
I think this was part of what Elon Musk was saying when he promised like maximum excitement. Like they really put the spacecraft through the ringer on this mission and like damaged it deliberately and put it in like very stressful situations just to see what it would do. But talk a little bit about the payload deployment mechanism. I thought that was really cool. It almost looked like a bicycle chain, like going back and forth, shoving
Yeah.
those things out the
So
door.
from what I understand, the dummy Starlink satellites are like lighter and smaller, more similar to what the next generation of Starlink satellites will be, and you just see them all sort of stacked up in the spacecraft. And then, like you said, there's like almost like a bicycle chain mechanism that's just rotating through and like pushing them out the door one after another. It's like very cool to see.
It was cool. It was really interesting to see video footage from inside the spacecraft, like as it was like doing its thing all autonomously. It was very cool.
And that footage was cool. And then also the footage of the actual launch from under the launch pad. Did you see that? Where like
Yeah.
you can see all the engines firing. That's insane. Like I don't understand how you even capture that.
How they even do that.
Capture
Yeah.
that footage. Yeah.
Yeah. So basically the whole mission was like an hour long, splashing down in the Indian Ocean. Like we said, both the booster and the Starship itself were destroyed after landing in the water as planned. So anyway, really cool test. There's a lot of data for SpaceX to collect and keep to inform like the sort of continued revision of the Starship design. There'll be more tests to follow. Why don't we talk about sort of the characteristics of the Starship itself? All right, Brooke. So we've talked about Launch 10, which was a smashing success for SpaceX and a much needed one. Let's get into the characteristics of the Starship itself. Um, this is basically like the largest and most powerful rocket ever launched. It's nearly 400 feet tall. It's like 397 feet tall. For comparison, the Saturn V with the Apollo capsule was 363 feet tall, so a good 30 feet shorter. The STS, the space shuttle, with its, its what do they call them?
SRVs.
SRBs and the ET, the big orange
Yeah.
external tank, all of that together was 184 feet tall. So SpaceX Starship, much larger, the diameter, similar range, right? I think the external tank of STS was like 27 feet. I think the diameter of the Saturn V was like 33 feet. The Starship's kind of right in the middle there at 30 feet in diameter. But gross liftoff mass is the crazy one. This thing weighs 11 million pounds.
Yeah, I can't wrap my head around how big that is at all. That's crazy.
It's so huge and has a massive payload, can bring 330,000 pounds to orbit. Um, and it's doing it with an interesting propellant as well. It's methane and liquid oxygen. And I've read that the reason why they designed the Starship with methane is because they think that that's like the most useful propellant for like in situ like resource extraction. So
Interesting.
like if basically methane can be synthesized
Yeah.
because it's a very simple molecule. It's just what CH4.
Yeah.
Um, and so the idea is you could, in theory, like make it on the moon or Mars or somewhere else. What other characteristics of the Starship do you think we should cover?
Yeah, I think the most interesting thing to me about the ship itself, or the rocket as well, is that it's all made of stainless steel, which is like pretty uncommon for rockets to be made of stainless steel. Traditionally, like aluminum alloys or carbon fiber. But because it's fully reusable and going to be launched over and over again, right? The focus is on how many of these can we make, how quickly can we make them, and stainless steel is kind of like the perfect material for that. It's heavier than aluminum or carbon fiber, but it's like super resilient at really high temperatures, really low temperatures, which is massively important for launching
Right.
a
So I
rocket.
think there are issues with carbon fiber with like it becoming brittle at cryogenic temperatures.
Right, which you wouldn't think of rockets getting like very cold, but even during the launch, right before they're in space, the liquid oxygen, methane has to be kept at like super, super low temperatures, like negative 300 degrees Fahrenheit, and then it's pumped into the ship at the last minute, which is when you see all the condensation and the ice like breaking off of the outside of the ship. But also, stainless steel just looks cool.
It looks really cool. And of course, it's covered in like thermal protection tiles and things like that. The other sort of like basic fact that we should mention is that it's two stages, similar to the space shuttle. Of course, Saturn V was three stages, but really just two stages. Just the super heavy booster, and then the Starship sitting on top of that.
Right.
That fire off, and are will both land autonomously.
Yeah, to be reused like infinitely, kind of, which is cool.
And it's an interesting thing too. I've often wondered about this. With the space shuttle, re-entry for the space shuttle was completely unpowered, right? So it re-entered the Earth's atmosphere like a glider, and at 25,000 miles an hour,
Yeah.
and like the pilots had to execute like a bunch of really crazy maneuvers, like exaggerated S turns and things like that, to essentially shed speed, um, and get ready to land. And I think they've landed at roughly, I want to say like I watched the space shuttle landing the other day on YouTube, and I think like they did like the main gear. They touched down with the main gear at like 200 miles an hour, and then it slowed to like 185 or like 200 knots per hour,
Hmm.
or 200 knots, and then slowed down to like 180 to touch like the nose gear. And so they had to get that's a lot of speed that has to be shed, which essentially means a lot of friction, which
Yeah.
means a lot of heat,
Yeah.
and it made me think about just the entirely different model of the Starship, which is, of course, a powered reentry where you have a giant rocket slowing you down, right? like you're firing a rocket in the other direction against the Earth, or against your own combustion chamber. Technically, that's slowing you down. And I just wonder, like, what kind of impact that has on the stresses that the thermal protection system encounters, and the
Hmm.
heat and things, and if that's like actually like it's even though it looks crazier, if that's actually like a safer way to slow yourself down
Yeah.
than to just be like swinging this glider like through the atmosphere like a crazy person, like trying to like
Yeah. The space
and
shuttle is
then getting
crazy.
like one chance to like hit
Yeah.
this like runway at exactly the right
Yeah.
angle.
I do know that the like upon reentry, it's under less it's like a lower G's than space shuttle or like a traditional capsule, like coming back to Earth, which is interesting.
Yeah, yeah. So that powered reentry, I think, is probably crucial for like the reusability of the spacecraft. What else? I mean, you know, I guess the other, just sort of the main thing. We covered the payload, just 330,000 pounds, and then total mass to orbit, 550,000 pounds, much larger than either Saturn V, which was 330 or 310,000 pounds to orbit, um, or the space shuttle, which was 171,000 pounds to orbit. And it's interesting too. I mean, to me, one of the things that's really interesting is that the Saturn V, like we watched the Starship do a pretty like small like routine mission for what the
Hmm.
Starship is
Like
eventually going to be
ultimate
designed for.
goal.
Like, the Saturn V was a moon rocket, therefore it like has to escape the Earth's gravity to a certain extent, right? To like to a much greater extent than the space shuttle did, right? You have to have a lot more thrust. You have to get going a lot faster to get to the moon, to get out that far.
Hmm.
And it's still like the liftoff thrust, the thrust of the engines is still much, much lower than the Starship. So like,
Mm.
it's just interesting to think about the test launch, or test flight 10, while it was so impressive and hit all these different marks that SpaceX was looking for, it's still like, you know
A fraction
a
of
fraction of the capability
ultimately what it's going to be able to do.
of what the system is even designed to do.
Yeah. 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 I mean, like, it's not news for SpaceX to be launching 8 Starlink satellites, right? They're doing that like almost every day.
Yeah.
Yeah. So ultimately, it's going to be doing a
And the
lot more.
next step will be to, I think, demonstrate. Eventually they're going to have to do like, because of the success of this flight, they're going to do like orbital tests, and then eventually they'll have to do like on orbit refueling, which will be really interesting.
Yeah. I'm excited to see how that works out. It's going to be interesting.
So we've talked about the test flight. We've talked about like the basic characteristics of the Starship, spacecraft and launch system. Now I think we should get a little bit into like where and how it's made. One of the things that's really cool about the Starship is that it truly is an American manufacturing story. Most of it's actually built in Texas, isn't that right, Brooks?
Yeah, yeah. Most of the components are all built at Starbase in Boca Chica, Texas, which is like the primary location for Starship.
Yeah, they like, and they have like various suppliers and stuff, scattered across like Texas, and they get things from, I think like the Raptor engines are made in McGregor, Texas. Those are like the sea level Raptors with like gimbaling and stuff like that. The vacuum, or like space sort of like vacuum optimized Raptors, are made in Hawthorne, California. They get a few other things. I think that there's a place in Florida that has like made these like this like slurry for the ceramic, thermal protection
Are they ceramic or are
tiles.
they like a silicon
Uh,
silica?
There's some sites in Florida that have like long specialized in the production of like the silicas for the thermal protection tiles. Starbase gets them from there, but basically the thing is made at this place in Boca Chica, Texas, called the Starfactory, which is a 1 million square foot facility They take in like I said, like steel coils from this mill in Sinton, Texas.
Like 3 hours north of Boca Chica, so not a far like journey for the steel.
For the flatbed truck. They get the steel in, they uncoil it, put it into these huge like rings and start like welding them together and stacking them up. Um, it's a really interesting facility. It's massive. There are going to be these like bays in it that the places, these vehicle assembly bays that are hundreds of meters tall. But I think what makes it most interesting is that once you realize that the Starship that was in the 10th test flight was ship 37. And so if you rewind and go back to the space shuttle program, which I think is a fair comparison because that's really the spacecraft with like the most similar capabilities in terms of like payload, crew size, and just like on orbit like things it could do. Um, I think NASA built one like test version of the space shuttle called the Enterprise that was just launched from like a modified 747. I think they did like a 15,000-foot test and like a 20 something thousand foot test just to make sure that it could actually fly. But then they went ahead and built, four space shuttles. They lost the Challenger. Um, then they built I think they built they built one to replace it, and then they lost the Columbia in 2003, and were left with like a fleet of three. Um, SpaceX is taking an entirely different approach to the manufacturing of its spacecraft. Right, it's a high volume approach. Right, they've already built 37, and we haven't even had like like an operational flight yet.
Yeah, I think that approach is super interesting, like the emphasis on failing fast and kind of failing first almost, and so you iterate and iterate and iterate to figure out what works before you move into, like, automating the production.
Yeah, the idea seems to be like you build a prototype spacecraft, you run it really hard until something breaks, you analyze the cause of that failure, fix that system and make it a lot more resilient, run it again until it breaks, until something else breaks, right? And you fix that. You keep doing that until all of your like the sort of the weakest links in the spacecraft are all brought up to like a reasonable safety margin for operational missions.
Yeah, it's so, like, you think we're on block 2, so ship 37 is the penultimate, like, block 2 V2 Starship,
Yep.
and then they'll move into block 3, but even this ship is different, right, than the one that came before it, 36 or 35, because 'cause they're constantly iterating, tweaking, changing things.
Yeah. And I think like that it's fat. The reason why like the Starship like manufacturing is so fascinating is because SpaceX intends to build hundreds, if not thousands, of Starships. And so you just think about the entire like spacecraft and the process of building it completely differently than if you're only planning on ever building like four or five of them, right? Um, it has to be very simple. It has to be very streamlined. It has to be something that works at scale that you can make mass quantities of.
I think what's interesting to me is that you can see, like, in the architecture of Starfactory, it sort of mirrors the, like, manufacturing philosophy, right? Where they started in these tents, and they're just, like, prototyping, figuring out what works, figuring out what works, and then they move into the actual Starfactory, and even, like, the shape of Starfactory mirrors the way that the rockets are built, where, like, you have these roof lines that get progressively taller as the ship moves through the assembly line and gets stacked up and welded together, which is just very cool. It's very cool to think about that, like the way that they mirror each other.
It's very the fact that Star Factory started off in these giant open air tents reminds me especially of the sort of production hell that Tesla went through. I think in like the 2019 period when it was running into a lot of issues scaling Model 3
Mhm.
production and deliveries, and there were some major problems with the robotics in the factory, and basically Elon ended up going in and like stripping a bunch of stuff out and then rebuilding these like assembly line processes in tents until they could work out all the issues and then re-automate. And since then, he's really emphasized automation last.
Right.
And basically, the idea is that, yeah, you start with like a super manual, flexible process. And then as you work out all the kinks, you slowly bring in more and more automation as there's no point in like automating a task that isn't 100%
You
correct,
don't
or
know. Yeah.
automating something in a way that like whether it's a certain like sequence of events that like artificially like puts a bottleneck on the entire process,
Right.
right? You want to like automate things in a way that keeps every sort of like station moving at the same speed. um that's really interesting. They started building it in 2019. By 2020, 2021, they had added some like really large buildings and finished it in, I think they finished it last year in 2024. Do you want to talk about a little bit about linear adjacent flow?
Yeah. If maybe anyone out there knows what that means, they can let us know. But that's a term that's been thrown around a lot to talk about the manufacturing process at Starfactory. I think maybe Musk is the one who like first coined the term, perhaps. But traditional manufacturing, right? We all think of like Henry Ford style assembly line,
Mhm.
where the conveyor belt itself is like setting the pace, right? So there's this like external clock that is dictating the workflow, and everything moves through at a consistent rate. But like you said, like that could lead to potential bottlenecks if one step in the process is really slow. Well, now everyone else is just like idly waiting, and then when that step does come through, now we're having to rush to keep up, right? So linear adjacent flow seeks to solve some of these problems with like typical manufacturing process.
Right, and to keep everything sort of moving at the same rate, to ensure that like velocity through the production line is continuous and doesn't slow down at any one station. So a lot of that has to do with like workstation like design, right? Making sure that like the way that you're chunking like the work processes into different pieces are all sort of like represent roughly the same amount of or same amount of time of work. But yeah, I do think I wonder how much of that is like a marketing gimmick and how much of it is just sort of like a sort of a Toyota or like lean manufacturing.
Sort of like standard.
Yeah, or like maybe
Yeah.
the next iteration of Toyota's improvements on like the Ford production.
Sure.
Um, it's hard to say.
I think one of the like features of a system like that is supposed to be too, right? You have all these stations in parallel that are working almost like on their own, but then as part of the whole. So if you find a way to speed up the process with that one station, it doesn't then like impact the rest of the line.
Right, like you don't want, say like a Starship is like coming down the line and it's avionics like you basically don't want them to like start building like the avionics system like once like the whole like gets to it. You want them to like have a whole process building that, and then it as those are finished they're like they come in like in a seamless way and are
Right.
installed. And so it does seem like it takes a lot of like very complex like timing and planning and logistics. I From what I understand, like SpaceX is far more vertically integrated than other aerospace majors, like Boeing or Northrop Grumman or people like that. Like they're making a lot of their components themselves. They use 3D printing even in parts of like Raptor
Mm,
engines. And I think it's very interesting because that was sort of the original way that assembly line production was made in the first place.
right.
Like if you go back to Henry Ford's like River Rouge plant, which opened up in 1928 and was making like I want to say it was making like 2 million cars a year. It's where the Model A was made. It was like the
Mhm.
best selling car of all time. Um, they brought in like it was something like 100 different. No, it was like it was like less than 100 like raw materials they brought in.
Wow.
So they would bring in wood, like just like lumber. They brought in coal and iron ore.
Yeah.
Like they literally like made their own steel. They made their own glass. They made their own rubber, like all on site. And that was because at that time, like the logistics and supply chains like weren't there.
Mm.
Like Ford couldn't find suppliers of these things that could deliver the quantities and quality of the materials to keep his production lines running on time. So it was
Right.
better just to insource everything. And obviously, during the course of the 20th century, that changed, um, and a whole ecosystem of suppliers grew up to closely like support the automotive industry and things like that. But it's interesting to see SpaceX and Tesla sort of
Almost going back to that.
going back. I think a lot of it has to do with their like radical designs from like first principles
Uh-huh.
that kind of would sort of go against or contradict a lot of like the baked in assumptions that suppliers in the space might have.
Well, and if you want to be able to like iterate really fast and like make changes and kind of do your own thing, right? You don't want to be beholden to the supply chain or like waiting on
Right.
other people. I also think that his like Elon Musk's concept of like the idiot index seems like it would play
Oh yeah, tell us
a
about
big
that.
part in that. So my understanding of it is like a pretty simple ratio, like maybe too simple in some ways, but useful for manufacturing, where you kind of look at a ratio of the cost of the raw materials compared to the cost of like the finished component. And 10 to 1 is like Musk's like optimal. Like if you're not hitting that 10 to 1 ratio, then you need to go back and think about like how do we make this more simple? Like how do we make this easier for us to manufacture? And so if you're bringing in just like raw materials, right, then you have more liberty to sort of like play with that
More visibility
ratio.
into like what's adding cost and
Yeah.
what isn't. Right. So a lot of his sort of like core design principles that I think apply to both like Tesla and SpaceX, make the requirements less dumb. So question and refine like initial specifications to eliminate unnecessary complexity and requirements. I think at Tesla they like had to sort of redo the entire way they made batteries. For SpaceX, it involves like simplifying the Starship design. And there's actually a great graphic online that shows the evolving design of like the Raptor engine over the
Mm.
years, and it becomes insanely simple. Like at the
Yeah.
beginning, it almost looks like the interior of like a U-boat or like a V2 rocket or something like that, with just like little pipes everywhere, like covering the whole thing, and you can't tell what's going on, and it looks like there's a million little things that could break. And like 2 or 3 iterations later, it's like so stripped down and streamlined. You wonder how it could even be capable of the same, producing the
Right.
same amount
Right.
of thrust as the original. Um, which brings you to another core like Musk design principle, which is like deleting non-essential elements, reducing redundant steps in Model 3 assembly, streamlining the Raptor production by reducing components, accelerating cycle time, so speeding up iterations through rapid prototyping. This is what we saw with all of those failures.
Hmm.
And again, because people weren't like NASA has had certain failed missions which were like not only disasters but like human tragedies,
Right.
like people losing their lives and stuff like that. And so I think people like aren't really accustomed to being okay with seeing like giant
Like
rockets
explode.
explode,
Yeah.
like in catastrophic ways. But that really is part of the design process, and it's really like absent a completely different approach to like engineering, quality control, like risk management, simulation and testing. Like it's the fastest way to.
And to build, I mean, literally building something that has never existed before, right? Also, like this is the first time that someone has attempted to build a fully reusable launch vehicle. So, like, failure is definitely an option, right? It's definitely part of the process.
Yeah. Um, so it's quite interesting to see a a space like a groundbreaking spacecraft be built in a way that's more similar to like Tesla Model 3 than it is to like an F-22 or a space shuttle for for that matter. It's, uh, it's fascinating and it'll be amazing. Like I think Ship 37 was completely constructed in like 5 months,
Right.
whereas a space shuttle was like it was like 4 years.
Right. And that's going to just get faster and faster too, right? Like I think
Should get faster and faster because, like you said, each of the well, even within Block 2, each of the starships they've made so far were unique from each other.
right.
Once all those kinks get worked out, and then Starfactory is like fully automated,
Yeah.
that will be they're expected to make them. They're supposed to ramp to like 1 to 2 starships per
day,
month,
right?
and then eventually per day.
Okay. Yeah, I think
Which seems insane because it seems like how could it be possible for there to be that much launch demand?
yeah.
But who knows when that will actually be?
I mean, we're right at the precipice of like whatever comes next in terms of launch demand though, I think. I don't think we have any way of knowing like what that's going to look like in 10, 20 years.
Right, we don't because people are proposing like using Starship for even like travel on Earth, like orbital
Sure.
travel on Earth, like
Sure.
like flying from
Like an actual space shuttle.
flying from like New York to Tokyo in like an hour
Yeah.
instead of like
That's
12 or
insane.
14 hours or
Yeah.
whatever. And then of course, like for Starship to get to the moon or to Mars, we're talking like 10 at least, like refueling flights, and so that generates obviously launch demand as well.
Right. Right.
Um, it's really interesting to see, and I think the more starships there are, the cheaper the launches will be, the cheaper it will be to get a kilogram of mass into orbit, and therefore, the more business models will make sense. Whether it's imaging, communications, on orbit manufacturing. I know that there are already like pharmaceutical companies that
Mhm.
do business on the ISS, because certain kinds of like molecules are more easily synthesized, like in microgravity,
Right.
things like that. And even material science, certain kinds of crystals, other kinds of high tech materials are more easily formed in microgravity. So yeah, there's really like there's a sense in which if you build it, they will come, and there's a whole concept of like induced demand where
Right.
simply like lowering the price of a commodity increases the
The
demand for
demand
it.
for it. Yeah.
Um, so it will be fascinating to see Star Factory scale, to see how quickly they can turn out the starships, because not only is Starship the largest and most powerful rocket ever launched, it's also probably like the fastest assembled orbital capable rocket ever launched.
Hmm.
Um, and it's not and Ship 37 was extremely slow
Relative to the pace that
compared to what
they're
they have planned.
yeah, forecasting. Yeah. I mean, I think 1,000 starships a year is something around there is kind of like the ultimate goal for the near future.
Right. And that's I think and that's based on the requirements to colonize Mars permanently, I believe. Because
Right.
I think
To be an interplanetary
I
civilization or
think
whatever.
that I think I've seen Musk's tweets about this, but I think that he said that they would need to deliver like 10 million tons of stuff to the surface of Mars to have a self-sustaining
That's
colony.
crazy.
And you think like, okay, the Starship's supposed to be able to deliver 100 tons to like near Earth orbit. How does that translate to Mars? It's much less. Um, Especially if you have to have like these elaborate and robust like life support systems for a
Right. Right.
multi-month journey and like all these people and stuff like that. So yeah, you're imagining like the just the design and construction and future plans of Star Factory, the manufacturing facility, compel us to imagine a future where there are like starships landing on Mars like every day,
Right.
like maybe
It's
even
just like
multiple starships landing on
routine.
Mars every day.
Yeah. In the same way that now, right, every week there's news about new Starlink satellites going up on Falcon 9s or whatever. It'll just be run-of-the-mill news.
Yeah,
every
or
morning.
like the Port of LA is expecting like 3
Yeah.
super container ships to like berth today. Like it'll be like that, which is exciting and like hard to imagine. It's an amazing time that we're in, and I think that the successful test of this Starship, especially with all the things that it was able to accomplish, um, it's like starting to make that future seem a little bit more real.
Within grasp. Yeah.
Brooks, any final thoughts on Starship?
No, I mean, I think it's interesting. Like SpaceX is kind of in like a league of their own right now, and I wonder, what do you think, like in terms of competition? Like, is it going to pick up at some point once this proves to be viable? Like,
Yeah, I think there are. I d- it's hard for me to imagine a private competitor coming out with a like super heavy lift capacity
right?
that directly competes with Starship. We have companies like Rocket Lab and United Launch Alliance that are doing smaller satellites delivering payloads to orbit.
Hmm.
And I think that's going to be like a very important part of the ecosystem. But the sort of the commercial space industry commentators that I follow have been talking about this in light of the Starship test. And they said that SpaceX seems to be, they basically said like 10 years ago they were a decade ahead of everyone else. And it seems like
Yeah.
they're still a decade
Just
ahead of everyone else.
the gap maybe is increasing, if anything.
Yeah, it
Yeah.
could be increasing if anything.
Yeah.
And I don't have a ton of visibility into like Chinese launch capabilities. Obviously, they've been operating their own space station that has 3 astronauts on board. They're planning a crewed lunar landing in 2030.
Right.
And so it's kind of like a new space race.
Which is a big part of the excitement around Starship, I think, is the Starship is going to be heavily involved, like you said, in Artemis 3, and then like getting America to the moon by the timeline that like acting NASA administrator Sean Duffy has outlined, like before China, hopefully, right?
Yeah, yeah. So more to come. I think Starship, it's a revolutionary American manufacturing story, and I think there are many more chapters of this story to play out.
Yeah, yeah. Well, thanks for having me.
Yeah, thanks for joining us, Brooke. You can check out the show at bringithome.us. You can listen to us on all of your favorite podcast players, including Apple. We have a YouTube channel. Be sure to like and subscribe, and stay tuned for our next episode.